You all doing? This is Dr. Nandi. For those of you who do not know me, I frequently lecture on math topics. I also solve problems online. There are lots of videos in my YouTube channel. Please take a look, and if you like those videos, please give me thumbs up and please subscribe to my channel by hitting the red subscribe button. Again, this is Dr. Nandi, and today we are going to talk about binomial probability of the number of heads when we toss a fair coin 3 times. That means we toss one coin one time, then pick up the toss, whatever we got, pick up the coin and toss it again, second time, note what we got, and then pick up the coin and toss the coin the third time. So we are tossing the single coin 3 times. So today we are going to talk about 3 tosses of a fair coin. 3 tosses of a fair coin. You may ask, what is a fair coin? A fair coin is one in which both sides have the same weights. That means there is equal probability of getting a head or a tail on each toss, and they are independent of each other. So since we are tossing the coin 3 times, that the possibilities are each coin we can get either a head or a tail. So each coin there are 2 possibilities, and they are independent. Each toss is independent of the other. What is independent? Independent means what you get in the first toss is not going to influence what you get in the second toss. So this is the number of possibility for the first toss. Then we are tossing the coin again, and what we get in the second toss is not determined by what we got in the first toss. So they are independent of each other. So the total possibilities are 2 times 2 for 2 tosses, because the second toss has also 2 possibilities, head or tail, and then multiplied by 2. Why are we multiplying? Because these are independent possibilities, independent of each other. What we get in each toss does not influence what we will get in the subsequent tosses. Is equal to 8, because each toss is independent. Each toss is independent. So now we toss the coin 3 times, okay? And let x be the number of heads. Okay? So x is a discrete random variable, number of heads in these t tosses. Discrete because either you can get 0 head, 1 head, 2 head, or 3 heads. So first we will look at the situation where we get all heads. So possibilities, the first possibility is each coin lands with head face up. Head, head, head. So we are looking for x, which is number of heads. In this case is 3. Okay. As I told you, the total number of possibilities is 8. Other can be, first 2 are lands head face up, the third one is tail face up. So here in this possibility, number of heads is 2. Or it could be head, tail, tail. In this case, number of heads is 1. Then it could be tail, tail, tail. Number of heads is, in this case, 0. Or it could be tail, head, tail. Number of heads is 1. or it could be tail, head, head. The number of heads is 2. Or it could be tail, tail and head. Number of heads is 1. Okay. And it could be H, first head, then tail, then head. In this case, number of head is 2. So this is possibility 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. We have exhausted all the 8 possibilities, and we are looking for number of heads in each possibility. So because these are independent events and there is equal probability, equal likelihood of any one of these possibilities. So the probability in each case is, this is called P of x, is 1 out of 8, 1 out of 8, sorry, yes, 1 out of 8, because there is only one of this, 1 out of 8, 1 out of 8, or 1 out of 8, and this is also 1 out of 8, this is 1 out of 8, and this is 1 out of 8. Now this 1 out of 8, each of them is 0.125 if we use the calculator. 0.125, 0.125, 0.125 equal to 0.125, equal to 0.125, equal to 0.125, equal to 0.125. Okay? So, now let's make another list of x. Remember, x is the number of heads, which is number of heads. And there are only three or four possibilities: 0, 1, 2, and 3. And we list the corresponding probabilities, P of x. 0 appears only one time, is 0.125. Okay? Then 1 appears 3 times. So 3 out of 8 is equal to 0.375. 2 appears 3 times also. So it is 3 out of 8 is 0.375. And 3 appears in the list one time only, 1 out of 8, or 0.125. Okay? Now, let's do x multiplied by px. X multiplied by the corresponding px. 0 times 1.125 is 0. Then 1 times 0.375 is 0.375. Okay? 1. Okay? X is 1. Then the next one is 2 times 0.375 is 0.75. Let me make sure. Yep. Okay. So this is 2. How did I get this number? Let me clarify from the top. Okay. So x multiplied by px is 0 multiplied by 0.125 is 0. Next one is 1 is the value of x times the probability 0.375 is 0.375. Next one is 2 is the value of x multiplied by 0.375 is 0.75. And the last one is 3 is the value of x, so this is 2, multiplied by the probability is 0.125 is 0.375. Now if you add this column, sum of x times px becomes equal to 0 plus 0.375 plus 0.75 plus 0.375 is 1.5. You may wonder, why am I doing x times px? Because the weighted mean definition is weighted mean is given by sum of, this is a symbol for sum, probability is kind of weight multiplied by value of x divided by sum of probabilities. Okay. Abilities. So in this case, the first case, you have 0 times 0.125, which is 0. Next one, you have 1 times 0.375. Next one, you have 2 times 0.2 multiplied by 0.375, 0 multiplied by 0.125. This is multiplication sign, so it should be okay. Then 2 multiplied by 0.375, and then 3 multiplied by 0.125. This is point, this is point. Okay. So you are multiplying each probability value with the corresponding x. And then you, on the bottom, you add the sum of the probabilities, which is 0.125 plus 0.375 plus 0.375 plus 0.125. 0.125 is the first probability, 0.375 is the second probability, 0.375 is the third probability also, the same. Second and third probability is the same, and 0.125 is the last probability. And then the weighted mean, or x bar weighted mean, becomes equal to on the numerator we added this is 1.5 divided by sum of the probabilities is also 1, so it is 1.5. Hence the weighted mean in this case, discrete probability distribution, okay, is sigma x, means each value of the random variable. Here we are looking at number of heads multiplied by its corresponding probability. Now I also want to tell you, this is a binomial probability distribution because you have head and tail. Okay. Also we note that for binomial probability distribution, the mean is n times p. Because we are tossing the coin 3 times, n is 3, times probability of success of getting a head in each trial is 0.5. N multiplied by 0.5 or 3 multiplied by 0.5 is also 1.5. Okay, this is same as what we established before, is sum of x dot px. So this is the formula, mean of a discrete probability distribution, discrete probability distribution. And this is the formula for mean of a binomial distribution, binomial probability distribution. And they are same as I showed you in this case. So what did we learn today? What we learned today is a binomial probability distribution is a discrete probability distribution. Here, for example, we are tossing a fair coin, that means same weight on both sides, 3 times. And each time we toss a coin, there is 2 possibilities. Either you can get a head face up or tail face up. Now we toss the coin second time, again we have 2 possibilities, head or tail. And the third time, head and tail, again 2 possibilities. Now each of these toss is independent. So total number of possibilities are 2 times 2 times 2, coming from 3 tosses of a fair coin, which is 8. We are looking at the number of heads. X is a discrete random variable. Why discrete? Because we will jump from 0 to 1, 1 to 2, 2 to 3. Okay. So what are the possibilities when you toss a fair coin 3 times? We already know there are 8 possibilities. What are these possibilities? This is the situation where all the tosses land head face up. So here the number of heads is 3. This is the possibility when the first 2 tosses land head face up, third toss is tail face up. How many number of heads? 2. The third one is where the first one is head, the remaining 2 tail face up. So number of heads is 1. The fourth one is all tail. Number of heads is 0 in this case. Because x is the number of heads, this is the discrete random variable we are interested in. The fifth one is tail, head and tail. 1 head. Next one is tail, head, head. 2 heads. Next one is tail, tail, edge. Head is 1. And the last one is head, tail, edge. Number of heads is 2. Because there are 8 possibilities and each of these possibility or each of this event is equally likely. So probability of each is 1 out of each. Why equally likely events? Equally likely events. 8 equally likely events. 8 is a number. So probability of each is 1 out of 8, which is 0.125. Then we put together the number of heads, which varies from 0, 1, 2 and 3. How many times 0 appears? Only once. Probability is 0.125. How many times 1 appears? 1 head, 3 times. 3 out of 8. This is 3 out of 8. 3 divided by 8. How many times 2 appear? 3 times. 3 out of 8. How many times 3 heads? It's 1 out of 8, which is 0.125. Then we multiply x times px. X is the number of heads multiplied by its corresponding probability. We find the sum of this column, x times px, and we show this is the weighted mean. The weighted mean of this binomial experiment, a probability experiment, is sum of the probability value of x, probability value, probability times value, this is times, okay, multiplied by. So let me clarify this, write it properly. Probability multiplied by value of x, okay, divided by sum of the probabilities. Okay, this is the definition of weighted mean. What are the weights here? The probabilities are the weights here put in. So in the numerator we multiply probability of each x times x. 0 times 0.125. Next is 1 times 0.375. We are adding this. Then 2 times 0.375 and 3 times 0.125. All this sum divided by sum of the probabilities, which we know is 1. So the weighted mean is of this Discrete probability distribution is sum of the probability times the value of x divided by sum of the probability is 1.5 divided by 1.5. So this is the formula for the weighted mean or the mean of a discrete probability distribution, which is also given by mu. This is mu, population mean. Okay. The mean of a binomial, this is binomial distribution, binomial probability, binomial probability distribution. Its mean is n times p. What is n? In this case, you are tossing the coin 3 times. What is the probability of head in each success, which is head in each of these tosses is 0.5. 3 times 0.5 is 1.5. Okay, this is same as sigma x dot px. So binomial mean is n times mean p. Okay, 1.5 is same as the sum of the probabilities times the value of x divided by sum of the probabilities, which is 1. And this is the formula, sum x times px is the formula for the mean for a discrete probability distribution, which is also binomial distribution is a discrete probability distribution. Why? Either you get 0 head, then you jump to 1, 1 to 2. No fractional value of head is possible. We also count or list the number of heads. What we proved here, the formula for a binomial probability distribution mean, mu equal to n times p, comes from the application of the formula of the mean for a discrete probability distribution, which is x dot px. Okay, so I will stop here today. If you have any question, any comment, please do not hesitate to write to me. Okay, shoot me a note and I'll respond to your note. And if you like this video, please give me a thumbs up. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And also please at that time hit the bell, notification bell, which will notify you every time I upload a new video, which I do almost everybody. It is my job, it is my duty to provide videos that are of help to you. So please subscribe to my channel and please give me thumbs up. That really motivates me to produce more interesting videos just for you. Again, thanks for watching. Take care. Have a nice day, and please do not forget to check me out tomorrow when I'll be coming with another video presentation. Thanks again. Take care. Have a nice day.